Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. Today we shall be looking at the scalars and the vectors. Physical quantities can be divided into two. That is, the scalar quantities and the vector quantities. We shall start with the scalar quantities. We shall look at the definition of the scalar quantities and some of the examples. Scalar quantities are defined as the physical quantities with only magnitude but no direction. Such quantities include we have mass, we have length, we have distance, we have speed, we have time, among others. All of these have magnitude but no direction. Whereas vector quantities are defined as the physical quantities with both magnitude and direction. Such quantities include we have force. When you exert force on an object, it takes a specific direction. We have weight. We all know that weight acts downwards towards the Earth's surface. We have momentum. We have velocity. We have acceleration. We have displacement, among others. Those are all vector quantities. Reason being, they have both magnitude and the direction. Now, after looking at the two categories, we also have what we call the resultant vector. A resultant vector is defined as the single vector which produces the same effect on an object as two or more vectors acting on the same object. And we can also have resultant force, since it is a vector. Resultant force is also defined the same way we define resultant vector. And therefore, resultant force is defined as the single force which produces the same effect on an object as two or more forces acting on the same object. And we shall consider moving from O to B along OB. This is the same as moving through OA followed by AB. And this shows that a single vector OB produces the same effect as adding OA and AB. And that is, OB, which is a single vector, is equal or has the same effect as these two vectors. That is, OA plus AB. Because when you add the two, you get OB. Meaning, this is a single vector with the same effect as these two vectors. So, in general, the resultant force is calculated, or resultant vector is calculated by adding all the vectors or all the forces. That is, if they are in the same direction. But when the forces or the vectors are in opposite directions, then the resultant force is calculated by subtracting. And therefore, we shall look at addition and subtraction of vectors. Addition of vectors occurs when the vectors are acting in the same direction, and the subtraction occurs when the vectors are acting in opposite directions. We have some illustrations to show that. We have in part A, we have two forces acting in the same direction, and therefore their resultant force is obtained by adding the two forces. That is, if we have 3 Newton plus the 4 Newtons acting in the same direction, we shall have a total sum, which is the resultant force of 7 Newtons. And in part B, we have the two forces acting in opposite directions, and therefore the resultant is obtained by subtracting the smaller from the bigger. That is, we shall have 4 minus 3 to give us 1 Newton. And that means that the 1 Newton is the resultant force, which has the same effect as 3 and 4 acting on the same object. Then we have another case where the two forces act on the same object but at right angles. So, for two vectors acting at right angles to each other, then the resultant is obtained by the help of the Pythagoras Theorem. That is, the resultant force will be the square root of 3 squared plus 4 squared, hence giving us the resultant force as 5. And therefore, we must also obtain its direction. Remember, a vector has both magnitude, which is 5, and direction, which we are yet to find. For the direction of the resultant force is given by the tan of the angle the resultant makes with the horizontal, and that tan theta is given by the vertical component, which we are calling the height, over the horizontal component, which we are terming to as the base. Hence, tan theta equals to the vertical component, which is 3, over the horizontal component, which is 4. Hence, giving us theta as the arctan of 3 over 4, which is 36 degrees. And that means that the resultant force of 5 Newtons is acting at 36.9 degrees above the horizontal, or above the 4 Newton force, because it is our horizontal component. That is how we get the direction of the resultant force. Let us look at examples. In our example 1, we are given 3 forces of 3 Newton, 5 Newton, and 7 Newton acting on an object A as shown below, and we are meant to find the resultant force. So we have object A, we have 3 forces. The 3 Newton and 5 Newtons are acting in the same direction, whereas the 7 Newtons is acting in the opposite direction. Now, how do we get the resultant force? Resultant force is got by, first of all, we shall add those that are acting in the same direction. The 3 Newton plus 5 Newtons. Then take away the one in the opposite direction, hence giving us 3 Newton plus 5, since they are in the same direction, minus the 7 Newton that is acting in the opposite direction, hence giving us a resultant of 1 Newton. That is how we shall find the resultant force acting on object A. In our example 2, we are given 2 forces of 12 Newton and 11 Newton act on a body of mass 0.2 kilograms. We are supposed to find the resultant force acting on the body and the body's acceleration. And this is our body of 0.2 kilograms, and these are the 2 forces acting on it. We have the vertical force of 12 newtons and the horizontal force of 11 newtons. Now, we've seen that for 2 forces, or for forces acting at right angles to each other, we employ the idea of Pythagoras Theorem. Therefore, the resultant force, RF, will be equivalent to the square root of 12 squared plus 11 squared, hence giving us the resultant as 16.28 newtons. And we are given the mass, which is 0.2 kilograms. Therefore, we are required to find the body's acceleration. So, how do we get acceleration? From force equals to mass times acceleration. Therefore, acceleration equals to force over mass. Now, we use the resultant force over the given mass to get the acceleration of the body. That is how we shall get the resultant force and its acceleration. In our example 3, we are given the figure below showing 5 forces acting on a 250 gram mass. We have vertical components and horizontal components. The question is, we calculate the resultant force on the body, the direction of the resultant force, and the acceleration of the body. Now, since we have many forces, therefore, we must first get the resultant horizontal and resultant vertical. After getting the 2, that's when we can determine the final resultant force. That is, this is our body acted upon by these forces. Hence, the resultant horizontal force will be, we shall consider the resultant forces and they are acting in the opposite direction. Hence, we subtract the smaller from the bigger, which gives us a resultant of 5 newtons. That is horizontally. Vertically, we have 3 forces, 2 acting downwards, 1 acting upward. Therefore, since we have two forces in the same direction, we first add them. That is 13 plus 8, which gives us 21. Then you take away the single force acting upward, which is 9 newtons, hence giving us the resultant vertical force of 12 newtons. Now, we have the resultant horizontal of 5. We have got the resultant vertical of 12. However, it is acting downwards. We now get the final resultant force. That is, we shall have the resultant vertical, which acts downward, and resultant horizontal acting horizontally. So, we use the Pythagoras Theorem to find the resultant force. That is 5 squared plus 12 squared under the square root, hence giving us 13 Newton as the resultant force. Then its direction will be given by the tan theta of the vertical component over the horizontal component. However, theta will be acting below the horizontal or below the 5 Newton force. Hence, it will give us an angle of 67.4. However, acting below the 5 Newton force. And hence, we shall conclude that the resultant force is 13 newtons acting at 67.4 degrees below the horizontal or below the 5 Newton force. And lastly, how do we get its acceleration? We shall use our formula, which is force equals to mass times acceleration, hence giving us acceleration as force over mass. We change our mass, which was 250 grams, to kilograms, hence giving us 13 over 0.25, which gives us an acceleration of 52 meters per square second. Lastly, let us have example 4, which will be our last example concerning resultant force. In example 4, we are given two forces of 6 newtons and 80 newtons acting on a 2 kilogram body as shown below. We are supposed to calculate the acceleration of the resultant force. However, this question needs acceleration, but you cannot get acceleration without getting the resultant force, because it is the resultant force that gives the body the acceleration. Hence, before we find the acceleration of the body, we start with finding the resultant force acting on the body. So we have two forces, 6 Newton and 80 Newton, acting at an angle of 30 to each other. Now, for such a setup, there are 3 ways of obtaining the resultant force, which will give us the acceleration. One is using the graphical method. In graphical method, we shall need to draw the accurate diagram and take measurements. However, we can also use the Consignee Rule, or we resolve forces horizontally and vertically. Now, we shall we shall look at the last two methods. We shall start with using the consignee rule. For the consignee rule, these are our forces acting on an object at point O. Now, we shall trace the path for the resultant force and use the consignee rule, which says that a squared plus b squared plus c squared minus 2bc cos A. Therefore, in this case, A is the resultant force we want, and the angle of A is 150. Since this is 30, this is also 30 because they are alternating, and if this is 30, a straight line has up to 180, which makes this 150. So we have the angle corresponding to the resultant as 150. Then we have the 2. This can be our B, this is C, this is A, and we have the angle A. Hence, we shall have the resultant squared equaling to 8 squared plus 6 squared minus 268 cos 150, which gives us a resultant of plus or negative 13.80 newtons. That is how we shall get the resultant force using the consignee rule. Or we can even get the resultant force using resolution of forces. That is, we resolve vertically and horizontally. We shall get the total horizontal component. That is, we have 8 is purely horizontally, but the 6 newtons has both horizontal and vertical component. The horizontal component of 6 newton is given by 6 cos 30. So we added the 8 plus 6 cos 30 to give us 13.196 newton as the horizontal component. Then we also find the vertical component. Since 8 is acting horizontally, it has no vertical component. But the 6 newton has a vertical component, which is 6 sine 30, hence giving us 3. So after getting the horizontal and the vertical components, we now get the resultant by getting the square root of 3 squared plus 13.196 squared, hence giving us the resultant force as 13.53 newtons. And from that, we can now get the required acceleration of the body, which is the force over mass. Have got the force, we were given the mass in the question. So that gives us an acceleration of 6.77 meters per square second. That is how we deal with the resultant forces. Otherwise, don't forget to subscribe. We meet in our next video. Thank you.